This is Captain Chaudhari. Today I'm going to talk on a different subject than what I was doing these days. I was doing the videos on naval architecture. But today I thought that I would start a new concept, that is astronomy, nautical astronomy. Well, let me introduce myself before I start taking this lecture. I have been teaching the students in Lal Bahadur Shastri Nautical College, and then MMCI, and then MASA, and I was heading an institute in Dehradun, and right now I'm staying in Dehradun. So I've been teaching this subject, that is navigation and principles of navigation, to all the levels, right, since 94, right? Last 10 years or so, 10, 15 years or so, I've been teaching astronomy to the extramasters candidate. Presently, I'm teaching astronomy, naval architecture, and environmental sciences to the extramaster level. So I thought the way I teach astronomy, the way I teach principles of navigation, after all, principles of navigation is an art. It's an art of navigation. Everybody does not teach it. Everybody does not like it. It's not everybody's cup of tea. Since I belong to the generation who have navigated through oceans using astronomical sites, I am of the generation who's always promoting the principles of navigation, the astronomical navigation, to the students. I have been teaching this subject since 94, both the practical and principles of navigation. I thought that I would do some videos so that the present generation and the future generation could be connected to the traditional, conventional method. So this is for them. This is dedicated to them. So in my first video today, I would like to talk about certain basic terms. The definition or the explanation may not be the conventional explanation, but I feel all those terms, all those definitions which are important to understand astronomy and astronomical navigation, I should be talking about them. The first thing I will talk about is the great circle. What is great circle? Well, great circle is a circle on the surface of the sphere. I'm not talking about within the sphere. It is a circle on the surface of the sphere, right? Whose plane passes through the center of the sphere, right? So if you can draw a circle on the surface of a sphere whose plane passes through the center, it should be great circle. Great circle on the surface of Earth is also considered as a circle or a route along which the distance between the 2 points is minimum. I can describe great circle in many ways. I can also say that if you cut a sphere along the plane of great circle, it will divide the sphere into 2 equal halves. So what is the importance of great circle? When we travel from one place to the other place on Earth, if we go by great circle on the normal chart that we use, that is the Mercator chart, we might feel that we are doing extra distance. We might feel that we are going excessively to the northern side, but actually that is the smallest distance. Great circle is the smallest distance between the 2 points. Now, I will give one example of great circle which you will definitely find interesting. Suppose from New York we want to come to India, and let's assume that, I'm not saying that it has to be there and an airport will be there which is diametrically opposite to the New York airport, but assume that in India we have an airport which is diametrically opposite to the airport in New York, right? The interesting thing is whichever way we fly from New York in the direction of north, in the direction of south, east, west, northeast, southwest, anywhere. So long as we go along the great circle route, we will reach the other airport in India by shortest route. Diagrammatically, I can explain you this way, that suppose this is New York and this is Indian airport. I can fly like this, I can fly like this, I can fly like this, I can fly on the other side. Whichever route I take, I will reach India by the shortest route. It means that from this aircraft there is one plane which flies this way and another plane that flies this way and another plane which flies this way and one more flying that way. All these planes will reach at the same time because diametrically opposite points have got millions and infinite number of great circles, right? So talking about how many great circles you can plot between the two positions. If there is one point over here and another point over here, the number of circles that can be drawn through these points can be infinite. Once again, infinite. Infinite number of circles can be drawn. This is also a circle with a radius extremely large. When there are 2 points on the surface of the earth, they can be joined by infinite number of circles, right? Okay. But if there is a third point also, right, on the surface of the earth, it is interesting to know that there is only one circle which can pass through these points, right? So we are talking about the various things that I can talk about, the circles on the surface of the earth. In conclusion, what I want to tell you, if there are 2 points on the surface of the earth, they can be traversed by any number of circles. But if there are 3 points on the surface of the earth, there can be only one circle which passes through all the 3 points. And incidentally, if you consider these 3 points to be the vertices of a triangle, then what we are basically drawing by drawing a circle like this is the circumcircle. The circumcircle. And circumcircle is drawn by, drawing perpendicular bisector on any 2 sides. Where the perpendicular bisectors meet, that point is the circumcircle. So I was talking about the different circles which can pass through the 2 points, right? I didn't say they're great circles. They're all small circles, right? Great circle is only one, and that particular circle or a line is part of the great circle. The plane passes through the center of the sphere, right? So what is small circle then? Small circle is also a circle on the surface of a sphere. But the plane of that small circle does not pass through the center of the sphere. So when we cut the sphere along the plane of a small circle, it does not divide the sphere into 2 equal halves. So if we talk about the earth, it is more easy to understand what is the small circle, what is great circle. So if we talk about the earth, a typical example of the great circle, assuming that earth is, spherical. Actually, earth is oblate spheroid. The polar diameter is less than the equatorial diameter. So we call that extra diameter causing a bulge on the equator, and we typically refer to it as equatorial bulge. So we were talking about the earth and assume for the time being that the earth is spherical. So equator, which is 0 degrees latitude on the earth, is a typical example. It's a typical example of a great circle, right? It divides the earth into 2 equal halves, the northern hemisphere and the southern hemisphere. All the meridians which are down, right, going slightly technical, but not all that technical. If we consider a point on the north side and south side which is equidistant from this equator. So considering that this is the equator, if we consider a point 90 degrees away, that means this angle is 90 or this angle is 90, or another point on the south side which is 90 degrees away from each point of the equator, that can be considered as North Pole and South Pole. Or if we assume that the Earth's axis of spin is to be imagined, which will be perpendicular to the plane of equator, it will pass from north and south geographic poles. So now I was saying, if we consider the Earth to be perfectly spherical, the equator is a perfect example of great circle, and these poles which are there, if I draw the partial great circle through these points, can I say that these are the meridians? These are the meridians because they start from North Pole and finish at South Pole. So they are in a way a semi-great circle. Semi-great circle running between the poles are the meridians. So these are the meridians. right? Similarly, I can show the meridian this way. Now, if I draw a circle, like this on the surface of the earth, you can see that the plane of the circle will not pass through the center of the earth. These are the typical examples. These are parallel of latitude, and they are perfect examples for the small circles. So it is easy to understand great circle and small circle with the graticules of the earth, right? Here, I would also like to tell you that if I consider the east-west distance between the two meridians in a particular latitude, this is called departure. But if I consider the east-west distance in between these two meridians at equator, this is called d long. So you can see from the diagram, d long is always more than or equal to departure. At equator, departure and d long are equal. There is a relationship. So I'm not going extremely technical. I'm doing only those things which will help you to understand nautical astronomy. And nautical astronomy is not a difficult subject. So everybody knows the east-west distance between the 2 points is departure, and the distance measured at the plane on the plane of equator, or if we consider this distance in terms of degrees and minute, the same amount of value in degrees and minute you will find at the pole. So angle measured at pole or the arc of equator between the two places, between the two meridians, is called d long. And here I must tell you the relationship between the departure and d long, as departure upon d long is equal to cos of the latitude. Latitude means, if we consider this point here and this point here, what is the angle made at, so this approximately for the time being can be considered as the latitude between this and this, the angle measured at the center of the earth. For the time being, let us understand this definition. So departure upon d long is equal to cos of latitude. So to the beginners, I just wanted to talk about these basic things. What is great circle? What is small circle? What is departure? What is d long? Now, one more thing I would like to tell about the great circle. It's a very mysterious thing. Very mysterious thing. Now, I told you this meridian is also part of the great circle, and equator is also a great circle. If I move on a great circle, I either move east or west. I either move north or south. But on that great circle, if that great circle has got the east-west component as well as north-south component, after some time the north-south component will reverse. If I'm going north at some given time, at some point of time, I will start going south, and that point is called vertex. For example, if I consider a great circle this way and I am going on along the great circle, at this point the north component will become south, and that is called northern hemisphere vertex. Similarly, there is a southern hemisphere vertex. But there is an interesting thing which I wanted to share with you, that if the great circle has got westerly or easterly component, when I look at the earth from front, I must write down V here. V means if I go that way, I'm going eastwards. If I go this way, I'm going westward. No thinking twice about it. So if I'm going this way, I have easterly component. The interesting thing is, if I have easterly component in a great circle, that easterly component can never become westerly component. The way northerly component becomes southerly component, the easterly component can never become westerly component, and vice versa. Well, that's it for today's session. In the next session, we will talk about a few other things.